This lesson, we are going to learn how to do curve sketching. Step 1. Factor the function fully. Step 2. Find the following fine information in order to sketch. First, determine the domain of the function. Second, find both x-intercepts and y-intercept. Third, using the restrictions to find any vertical asymptotes and holes. Then, we check the end behavior of the vertical asymptote. Fourth, find the horizontal and the oblique asymptote. Then we check the end behaviors either on the horizontal or the oblique asymptote. Fifth, find the crossover points. Those are the points where the function goes through either the horizontal asymptote or the oblique asymptote. Example 1. Given the function f(x), step 1. Fully factor the function f(x) to get a simplified rational function 1 over x plus 1. Next, let's write down the restrictions to help us to find the domain. We know x minus 3 cannot be 0, means x cannot be 3. X plus 1 cannot be 0, means x cannot be negative 1. So now, we can find our first information domain. X is element real such that x cannot be negative 1 and 3. Second, let's find the x-intercepts and y-intercept. For x-intercept, we have to let y equals 0, substitute into the function, then we get 0 equals to 1, which is not possible. Therefore, we say we do not have any x-intercept. For y-intercept, we let x equal to 0 to substitute into the function to find the y value, we get y equals to 1. So for y-intercept, we either write 1 or we write as a coordinate 0, 1. Third, let's use the degree of the numerator and degree of the denominator to determine the horizontal asymptote or the oblique asymptote. As we can see, degree of the numerator here is 1 and degree of the denominator is 2. Since the degree of the numerator is less than degree of the denominator, so we know the horizontal asymptote will be at y equals 0 and we do not have any oblique asymptote. Let's check the end behavior of the horizontal asymptote. On the right end, when x is approaching to positive infinity, we let x to be 1000 to substitute into the function to find the y value. We get y equals 0.000999, which is almost 0, but a little bit higher than 0, so we say y is approaching to 0 from above. On the left end, when x is approaching to negative infinity, we let x to be negative 1000 to substitute into the function to find the y value. We find y to be negative 0.001, which is almost 0, but a little bit lower than 0, so we say y is approaching to 0 from below. Since there is no oblique asymptote, so we don't have to check the end behavior for oblique asymptote. Fourth, let's find the vertical asymptote and holes. So we know there are two restrictions. However, in the simplified rational function, we only see 1 in the denominator now. Therefore, we say the vertical asymptote will be the one that remains in the denominator, which is x equals to negative 1. Then x equals to 3 becomes the location of the hole. But we also need to find the y value of the hole, so we have to substitute x equals to 3 into the simplified rational function to get the y value to be at 1 over 4. Therefore, we know the location of the hole is at 3 and 1 over 4. Let's check the end behavior of the vertical asymptote. When the function is approaching to the vertical asymptote from the right, we say x is approaching to negative 1 plus. Then, we let x to be negative 0.999 to substitute into the function to find the y value. We get y value to be at 1000, which means y is approaching to positive infinity when x is getting closer to the vertical asymptote from the right-hand side. When the function is approaching to the vertical asymptote from the left, we say x is approaching to negative 1 from the left. So this time, we let x to be negative 1.001. Substitute into the function to find the y value, we get y value to be at negative 1000, which means y is approaching to negative infinity when the function is approaching to the vertical asymptote from the left. Lastly, we have to find the crossover points. We need to know where the function goes through the horizontal asymptote. So we let them equal to each other to find the intersection point, and we will see 1 equals 0, which is invalid. Therefore, there's no crossover points. Finally, let's put all the information that we have on the graph to sketch the curve. So first, we know there's a y-intercept at 1. Next, we know there's a horizontal asymptote at y equals 0. And a vertical asymptote at x equals to -1. And with a hole at 3 1/4. Let's do the end behavior. On the right-hand side of the function, we know it's above the horizontal asymptote. And on the left-hand side of the function, we know it's below the horizontal asymptote. And on the right-hand side of the vertical asymptote, we know y is approaching to positive infinity, which is going up. And on the left-hand side of the vertical asymptote, we know y value is going down, going to negative infinity. Finally, let's connect all the information that we have on the graph in order to generate the sketch for our rational function. Example 2. Step 1. Let's fully factor the function gx to get the simplified form y equals x plus 4. Then, let's write down restrictions to help us to find the domain. X cannot be -3. Step 2. Now let's find the information to help us to do the curve sketch. First, we have to find the domain. We know x is all of the real numbers, but x cannot be -3. Second, let's find the x-intercept and y-intercept. For x-intercept, let y equal to 0. Substituting to the function, we know x equals -4. Therefore, we say x-intercept is at -4, or we can write as a coordinate, -4, 0. For y-intercept, we let x equals 0. Substituting the function, we get y equals 4. Once again, we can write 4 as the y-intercept, or we can write as a coordinate, 0 and 4. Since there is no more fraction in the simplified form for gx, therefore, we do not have any of the asymptote. However, we do have a hole at x equals -3. So we have to substitute x equals -3 into the simplified form for gx to find the y value. We get y value is at 1. Therefore, we know the location of the hole is at -3, 1. At the same time, since there's no asymptote, so we will not be able to cross over the asymptote. Therefore, there's no crossover points either. Finally, let's put the information on the graph. We have an x-intercept at -4. We have a y-intercept at 4. We also have a hole at -3 and 1. Now, let's draw a linear line to represent our function gx. Example 3. Step 1. Fully factor the function f(x) and write down restrictions. X cannot be 3 and x cannot be -1. Step 2. First, let's find our domain. X is all in the real such that x cannot be -1 and 3. Second, let's find the x-intercepts and y-intercept. For x-intercept, let y equals 0 to find x. X will be at 4. Then, for y-intercept, we let x equals 0. Substituting the function, we get y is going to be at 4/3. Third, horizontal asymptote or an oblique asymptote. Let's look at the degree of the numerator, which is 1, and degree of the denominator, which is 2. Since the degree of the numerator is lower than the degree of the denominator, therefore, the horizontal asymptote will be at y equals 0, and we do not have any oblique asymptote. Let's check the end behavior for the horizontal asymptote. On the right end, when x is approaching to positive infinity, we put 1000 into the x to find the y value. You can see this y value is a little bit higher than 0, so we say 0 plus. On the left end, when x approaching to negative infinity, we put -1000 into the x. We get y value to be -0.001, which is a little bit lower than 0, so we say 0 minus. Fourth, let's find the vertical asymptote and holes. Look at the reduced, simplified rational function. We still can see those two restrictions in the denominator. That means both of them are the vertical asymptote. So we say the vertical asymptote will be at x equals to -1 and x equals to 3. Let's check the end behaviors. When x approaches to -1 from the right, we use -0.999 as the x value. We get y value to be 1,250. So we say y is approaching to positive infinity. When x approaching to -1 from the left, we use -1.001 for x. We get y to be -1,250, which means y is approaching to infinity. When x approaching to 3 from the right, we use 3.001 as the x value. We get y value to be -250. That means y is approaching to infinity. Then we say x approaching to 3 from the left. We use 2.999 for x, y value to be 250. That means y is approaching to positive infinity. Since none of the factors from the denominator can be divided into the numerator, therefore we do not have any holes. Fifth, let's find the crossover point. We let the function equals the horizontal asymptote to find the point of intersection. We get x equals to 4. After that, we can either substitute 4 into the function to find the y value, or we can simply see y is 0 because that's where the horizontal asymptote is. Therefore, the crossover point will be at 4, 0. Finally, let's use the information that we have to generate the curve. So first, let's put the x-intercept and y-intercept on. Next, let's put the horizontal asymptote y equals 0 on, and the two oblique asymptotes. After we have the asymptotes on, then we put the end behaviors on. For the horizontal asymptote, on the right is above the 0, and on the left is below the 0. For the vertical asymptote at x equals -1, on the right is going up, and on the left is going down. For the vertical asymptote at 3, on the right is going down, and on the left is going up. Now, let's connect all the information that we have to generate the sketch for the curve. Example 4. Step 1. Factor the function gx fully to get the reduced form. Then we state the restrictions. X cannot be 2 and x cannot be -1. Step 2. First, let's find our domain. X is on the real such that x cannot be -1, x cannot be 2. Second, x-intercept, let y equal to 0 to solve for x. X-intercept will be at -4. For y-intercept, let x equal to 0 to find the y value. Y-intercept will be at 2. Third, determine the horizontal asymptote or the oblique asymptote. Since the degree of the numerator equals to the degree of the denominator, therefore, we have a horizontal asymptote and we do not have oblique asymptote. But how do we find the horizontal asymptote? We have to use the coefficient of the leading term in the numerator to divide it by the coefficient of the leading term of the denominator, which means y equals to 1 divided by -1, which is y equals to -1. Therefore, horizontal asymptote will be at y equals -1, oblique asymptote, none. Let's check the end behaviors. On the right end, we say x is approaching to infinity. We substitute 1,000 into the x. We get y value to be -1.006. So we know y is approaching to -1, but from below. On the left end, when x is approaching to infinity, we let x to be -1,000 to substitute into the function to find the y value. We get y is going to be -0.994, which is almost at -1 from above. Fourth, vertical asymptote and holes. Let's look at the reduced rational function. We still can see the restriction at x cannot be 2. However, we do not see the restriction x cannot be -1. Therefore, we know there is a vertical asymptote at x equals to 2, and there is a hole at x equals -1. However, we need to find the location of the y value of the hole. So we have to substitute x equals -1 into the reduced rational function to find the y value, which is at 1. Therefore, we know the location of the hole is at -1 and 1. Let's check the end behaviors. When x approaching to 2 from the right, we are using 2.001 for x to substitute the function to find a y value, which is at -6,000. So we know y is approaching to -infinity, as the function is approaching to the vertical asymptote from the right. When x approaching to 2 from the left, we use x to be 1.999 into the function to find the y value. We got y value to be 5,999, which means y is approaching to positive infinity when the function is approaching to the vertical asymptote from the left. Finally, let's look at the crossover. We have to find the intersection between the function gx and the horizontal asymptote y equals -1. We let them equal to each other to find the point of intersection. We see 0x equals -6, which is not possible. Therefore, we know we do not have any crossover points. Now it's time to generate the graph. Let's put all the information that we have on the graph. First, label the x and y axis and put our intercepts on. Then, let's put our horizontal asymptote y equals -1 and the vertical asymptote x equals 2 on the graph. Then, let's put an empty dot on where the hole is at -1, 1. Now, let's put the end behavior on. We know on the right-hand side of the graph, the function is below the horizontal asymptote. On the left-hand side of the graph, the function is above the horizontal asymptote. On the right-hand side of the vertical asymptote, the function is going down to -infinity. And on the left-hand side of the vertical asymptote, the function is going up to positive infinity. Finally, let's connect all the points that we have to generate our sketch for the curve. Example 5. Step 1, let's fully factor the function and write down restrictions. X cannot be 2, x cannot be -2. Step 2, let's find the information we need to graph the curve. First, let's state our domain. X is element real such that x cannot be positive -2. Second, find the x-intercept and y-intercept. For x-intercept, we let y equal to 0, substituting to the function to get x equals 0. For y-intercept, we let x equals 0, substitute 0 into the x to find the y value, we get y equals 0. Third, let's determine our horizontal or oblique asymptote. Since the degree of the numerator is higher than the degree of the denominator, therefore, we say there is no horizontal asymptote, but there is an oblique asymptote. We have to use long division to find the quotient, which is our oblique asymptote. So our oblique asymptote will be at y equals to x. Let's check the end behaviors. When x is approaching to positive infinity, we let x to be 1,000. Substitute into the oblique asymptote, we know the y value will be at 1,000, but when we substitute into the function, we get the y value is 1,000.004, which is higher than 1,000. Therefore, we say y is approaching to oblique asymptote from above. When x is approaching to -infinity, we let x to be -1,000. To substitute into the oblique asymptote, we get the y value will be at -1,000. However, when we put into the function, the y value is at -1,000.004, which is lower than the oblique asymptote. Therefore, we say y is approaching to oblique asymptote from below. Fourth, let's look for the vertical asymptotes and holes. From the reduced, simplified rational function, we still can see those two restrictions in the denominator. Therefore, we know the vertical asymptote will be at x equals to +2 and x equals to -2, and there will be no holes as nothing can be divided into the numerator. Check the end behaviors. When x approaching to 2 from the right, we use 2.001 for x. We get y value is almost at positive infinity. When x approaching to 2 from the left, we use 1.999 for x. We get the y value is approaching to negative infinity. When x approaching to negative 2 from the right, we use negative 1.999 for x. We see the y value is approaching to positive infinity. And when x approaching to negative 2 from the left, we use negative 2.001 for x. We can see y value is approaching to negative infinity. Fifth, let's find the crossover points. When the function is crossing over the oblique asymptote, there is a shortcut to find the crossover points. We have to let the remainder from the long division e equals 0 to find the x value, which means for x equals 0, then we get x equals 0. Let's substitute x equals 0 back to the oblique asymptote to find where the y value is. We get y is 0 as well. Therefore, the crossover point is at 0, 0. Finally, let's put all the information that we have on the graph to make a sketch. Label the axis, put the x and y-intercept on, put all the asymptotes on. Now, let's put the end behaviors on. We know on the right-hand side of the graph is above the oblique asymptote. On the left-hand side of the graph is below the oblique asymptote. On the right of the vertical asymptote at x equals 2, the function is going up. On the left-hand side is going down. And along the vertical asymptote x equals negative 2, on the right is going up. On the left is going down. Connecting all the end behaviors, now we have our sketch.